Good afternoon, everyone. Thank you for joining this second appointment of the IDEA4RC webinar series. We got today more than 50 registered participants, so let's wait just 1 minute to allow everyone to join. Thank you. Well, I will now start by shortly introducing myself. My name is Lidia Villanova, and I'm representing Alliance Against Cancer, which is the National Oncology Research Network in Italy. And as a Work Package 10 leaders in IDEA4RC, we are really committed in engaging the research and healthcare community in co-creating the data ecosystem that IDEA4RC is developing. So it is my pleasure to host this webinar and introduce our speakers today. So first of all, Eugenio, who is a software engineer at the University of Madrid and technical manager in IDEA4RC. Hi, Eugenio.
Hi, good afternoon to every one of you. And I don't know if you want that I present a bit myself or I do
Yes,
later.
please. Yes, Eugenio.
As Lydia told, I'm Eugenio Gaeta from University Politécnica University of Madrid, and I'm the technical manager of IDEA4RC. My background is computer scientist and biomedical engineering, and I'm working since more than 10 years in IT infrastructure for health, data standard, and distributed computing. And that's my very short background.
Thank you, Eugenio, for this nice introduction. And it is now my pleasure to give the floor to Unai for him to introduce himself. Please, Unai.
Okay, Lydia, thank you for the introduction. So I am Unai Zulaika. I am a postdoctoral researcher here at the University of Deusto in Spain. I am the leader of the NLP work package in the IDEA4RC project, and my background is mostly in machine learning and also in data modeling, where I have like some experience working with biomedical models and biomedical problems and issues. Yeah, thank you, Lydia.
Thank you to both our speakers. And now I would like to draw your attention on the agenda of today's webinar that you should be able to see. So after this short introduction, Unai will explain how clinical data coming from the different hospitals in the data IDEA4RC ecosystem will be harmonized to become interoperable. And then we will also learn how even data from unstructured sources, which means free text clinical annotations, will be automatically ingested into the data ecosystem by leveraging natural language processing. We will then have the first Q&A session where you are welcome to pose your questions by raising your hand, and I will unmute you. Otherwise, if you do not wish to be recorded, you can still ask your question by using the chat. Next topic that follows is how data are processed in a secure way that preserves privacy and complies with the European regulation on data protection. And this will be explained by Eugenio Gaeta, who will provide a deep dive into the innovative secure processing environment that IDEA4RC has developed. And after the last Q&A session, we will launch, as last time, a live opinion poll where you are welcome to share significant insights from your perspective on the different topics that have been discussed. Now, just a few words to emphasize that this webinar series has been launched within the framework of the IDEA4RC community, which we established with the objective to engage a wide and diverse group of stakeholders in the co-creation of the IDEA4RC data ecosystem. So if you wish to subscribe to our community, you will be invited to participate in upcoming initiatives where you can have a say and provide your feedback and recommendation on the project developments according to your field of expertise. The community was launched last year in June and welcomed as its first members the Huracan patient advocates. From there has now grown up to 49 members across different research and healthcare sectors, as you can see from the pie chart. So if you wish to join us, you can just scan the QR code and subscribe to the community to stay tuned on the next activities. And now I'm very glad to give the floor to Unai for his presentation.
Thank
Please,
you, Lydia.
Unai, if you can share your screen.
Yes, let me know if you can see it.
Yes, we can. Perfect.
Okay, perfect. So let me hide this. Okay, so again, good afternoon, everybody. First of all, before starting, I would like to thank Lydia for the invitation to the seminar, and also Chiara Sabelli, who did the slides, and also some of the IDEA4RC partners, such as FBK, Cleaninode, Engineering, and so on, because many of the things that I'm going to present today have been done in collaboration with them. So the title for the seminar is Automatising data extraction and Securing Data Storage. So basically, the idea is that we, Eugenio and myself, we will present the data flow in IDEA4RC. I will better explain this afterwards. So just a quick note, I will probably use many times the term NLP. So this stands for Natural Language Process, just for the clarification. Yeah, so coming back, first, I will try to make a brief recap of the IDEA4RC project, so we are all on the same page, and then we can continue from there. So IDEA4RC basically is a project which tries to create some kind of data space to facilitate the reuse of clinical data or cancers. So the idea is we are hosting some data that then can be used to perform some research questions and to answer some questions for clinicians. Currently, we are focusing on two rare cancer families, head and neck cancer, and also soft tissue sarcomas. So this figure kind of depicts the full project. So first of all, before anything else, I would like to notice that we have different hospitals. Okay, so here we have Hospital 1, Hospital 2, Hospital 3, and so on. In the IDEA4RC project, we have 11 different centers, and they are all connected to each other. Okay, so let's go little by little. Let's focus on the first hospital, or just the example of the first hospital. Here you can see that each hospital has some information, some databases, let's say. And then what we will do in IDEA4RC and what we are going to explain today is how we harmonize this information. We create some kind of common standard language. And then we also use natural language processing, NLP, to process text and input that information into the IDEA4RC ecosystem. Okay, so once we have this kind of table from here and also from here and from here, this means basically that information is ready to get retrieved for the clinicians and the researchers when they want to query the IDEA4RC ecosystem. In there, again, we will have head and neck cancers and sarcomas. Okay. So this is within the within the IDEA4RC ecosystem, which should be the blue circle. Okay. So in there, we are hosting like the 11 centers and all the information within the 11 centers. But additionally, we have a few extra layers that will be explained in future seminars, which are the federated learning layer, okay, which is powered by Vantage6, that is some kind of layer to retrieve all the information in a secure manner, okay. And it basically gets the researchers query all the hospitals in a federated manner. Then we have some metadata layer and some data governance layer also for handling some information regarding the data. So the idea is that in the end, users, whether they are researchers, clinicians, statisticians, or any kind of role, they will be able to use this tool, which is called Raven, which is basically a virtual assistant that helps them query the information and analyze the information coming from each of the 11 centers in the IDEA4RC project in a secure and federated way. Okay, so the idea is that we will have this tool that will help them do their work, basically. But today, okay, so this has been the recap for the IDEA4RC project. Today, we will focus only on this small part of the full figure, okay? Here, we will focus on how we populate the capsules, okay? So populating capsules means how we get the data from the original data sources in the databases of the hospitals, and then we move it to the correct database that we use for IDEA4RC, okay? And I will explain how we fill these databases, okay? And then Eugenio will talk about how once we get this kind of capsule, okay, here the technology that we use to store the data, he will talk about how this capsule is really secure and really powerful in terms of processing the data. So continuing, this is like the simplified overview of the full approach. So here we have the hospital database, and we want to move all the information from the hospital database, or at least that information that is interesting for us for the IDEA4RC project, to the IDEA4RC capsule. So then we can process the information within the capsule and provide the results to the Raven tool, to the end user of the IDEA4RC project. So I will explain this step, this blue arrow that comes from the hospital database to the IDEA4RC capsule, and then Eugenio will focus on the capsule itself, okay? A few notes regarding each of these steps. So the first step, as I already explained, is the process of populating the capsule. So we just find the hospital's data and put it into the capsule, okay? So for this, we have a few challenges. I will present them in the next slides. And then the second is where we store and we process the data, okay? Next, we have two main steps for the blue arrow, or for the first step, okay? The first one is what we call harmonization, okay? So the concept is quite easy. So we need to create some kind of a standard language, okay, for the data that we have in the IDEA4RC. So every capsule, so we have 11 capsules, one for each center. So every capsule can talk to each other and also to Raven. So then when a user is doing some research, asking for some information and wants to process the data, we really need a common terminology, a common understanding, and this is this step of harmonization, okay? This is done, has been done creating some kind of data model that I will explain also next. The second important part for this blue arrow here, for this step from the hospital database to the IDEA4RC capsule, is what we call extraction. So here is just, we need to dig out the information, the data in the original hospital database, identify where it is, and then we need to extract it and put it into the IDEA4RC capsule, okay? So for this, we have two different types of data. We have some data which is structured, This can be the age, the sex. So these are really common data or common information that can be usually extracted in a structured manner. So these are relatively easy to retrieve from the hospital database. However, there are like many information, and I will talk about this afterwards. There are many informations that are in the free text form. So we need to use some AI tools, some natural language processing tools to obtain that information and structure that into the IDEA4RC capsule. So then we can perform some analysis and do research with this information. Regarding the second step, Eugenio will probably better explain this. But the idea is that capsules are tools for holding data in a really secure way. And this concept is also quite important. The data within the capsules, okay, so capsules are hosted within each of the hospitals, and the data never leaves the capsule. So it never leaves the hospital, okay? The data is processed inside the hospitals, and what we return are the results, not the data per se. So the challenges. So regarding the harmonization, so data requires using the same data model, so the same language to understand each other and Raven. So I already explained this. And the second challenge that we have here is that extracting data from text is complex. So we need advanced tools for doing it. So I already said, we are using these natural language processing tools that are really the state-of-the-art models. That basically means that we are using the last models that came out in the last months to try to get the more information possible to the IDEA4RC environment. So this is a really hard task. So now I will first explain the harmonization step, which is basically the data model, and then I will continue with the natural language process. So regarding the data model, first I would like to explain what is a data model for those who do not know. So it is a specification about data. And here I try to provide some kind of analogy, and you can think about clothes. So how we store this information, okay? How we store the data. And if you think about the case of clothes, should we hang the clothes? Should we fold them? Or how are we storing it? Then where are we putting these clothes, right? So where are we putting this information? Should they go into the closet or in a chest of drawers or somewhere else? And then last but not least, how we interconnect the data. This is also really important in our use case. Should shirts go with pants in one section, or maybe should accessories like belts or ties be stored also together? So these kind of things, right? So we want to connect the information, to connect the data to better understand the whole picture of the information. So some characteristics about our data model. So basically we build the data model based on some relevant questions, some research questions that were performed by clinicians, or we think that will be performed by clinicians. And this information that we are storing here in the data model is patient basic demographic information, previous observations about the patients, diagnosis-related information, of course, disease progression, the extent of the disease, also information about treatments, and so on. So we have like a huge data model that where we only try to get the information that is relevant to perform research questions regarding rare cancers. So cancers are diseases that must be treated longitudinally, and this is really important for a use case, for our use case. That is basically, it means that we need to follow the temporal evolution, right? So when did the diagnosis happen? When are we performing the treatments? What is the outcome of the treatments? How is the patient? These kind of things must always be treated with their temporal evolution, and we need dates basically to record this temporal evolution. So this is also a big challenge for the data modeling. And last but not least, we have to unify the medical vocabularies. So each hospital may use different terminologies and different vocabularies. This can be ICD, SNOMED, and so on. So we needed to come to a common ground where we all are using the same codes and everybody can understand each other, basically. So in this slide, I'm trying to represent what we did. This is like the cancer journey of a patient. And here, probably you can see it really well. But here, what we are trying to represent is this temporal evolution. So if you follow this black line from here, this is the temporal line, okay? And there you should see a set of dates, okay? Then what we have is like many boxes and many arrows from here. So the boxes here can represent different things. So for instance, blue boxes represent treatments. Then we have some this kind of orange text where we represent the diagnosis, the state of the disease. For instance, here we have the remission, the recurrence, and so on. And then we have the arrows. So arrows are what I said before, that are these kind of interconnecting things between the different information that we have. Okay, so this is what we got with our data model, the information that we need to model, how it connects to how things connect to each other, and then how we put them in a temporal line. Okay, and this was done after lots of interdisciplinary work. This was a really hard task. We have many meetings, technical people, clinicians, and so on, and we got to this common understanding and common data model that is used in the IDEA4RC project. Yeah, so the result, as I said, is a fully harmonized data model that works as a bridge for other health standards. So there are other kind of standards used in healthcare, and our data model can be compatible with both of them, which these are mainly FHIR and OMOP. Also, it has some strong temporal relation, okay, as I just explained, and it is what we call semantically interoperable. That means that every center can use their own terminologies, or at least that we can provide an understanding between different terminologies for each of the centers. So here you have the link for the to the data full data model. I guess that Lydia will share the slides if needed. So you can access in there the full data model. This is just a huge Excel file where it is you can find everything represented there. Now, how we go from the data model to actual data. So once we had this data model, basically what we want to do is to get the information from the hospitals and put the information in the corresponding place within the data model, okay? So for this, we will dig out the hospital databases to find what we want, okay? This is, as I said, just what we specified in the data model. We really know what we are looking for. And there are two possibilities here. So we can find data which is already structured, as I explained before, sex, age, and so on. There are some common information that are usually structured within the hospital databases, but there are a lot of information. There is a lot of data buried in free text. Okay, so these are the free text. We mean basically notes the doctors write when a patient is visiting, or when they need to provide some result or some report on radiology or whatever. So there are many free texts that hold a lot of information which is relevant for us. So here NLP comes as the solution, right? So the idea is we will use these natural language processing tools, these models, to get the information, and we will put that into a structured way into our data model, so we can query the information, right? So next we go to the natural language processing. So what is natural language processing? Basically, it's an AI tool that lets us automatically extract information from text. Okay, so here we have this fantastic video that explains how we work. So basically, here you can see a full text note coming from a patient, 49-year-old male presence, blah, blah, blah. So we have a lot of information here. And what we want is to automatically identify some concepts or some information which is relevant for us. So for instance, here you see that there is some highlight here, 8 centimeters in diameter, okay? So this information is something which is relevant for us. That basically is stating that the value of T, okay, which is a specific value of the staging of a cancer, equals 2. So we want to extract information, okay? So we want to do this process automatically. We want a model that receives this text and outputs the T equals 2, okay? But we can continue doing this. We can get not only the T, but also other kind of values that are interesting for us. So in the next part of this slide, here you see that we have 2 different highlights. in green that gives us that n equals 0. Okay, so this is the second part of the staging for a cancer. We have the T, now we have the M, and we will have last the M. Okay, the M in this case is also obtained by identifying different parts of the text. In this case, the ones highlighted in blue, and we also report that M equals 0. Okay, so this is important for us. Why? Because we want to know the stage of the cancer, right? And we can only obtain this looking at the free text. So from here, we identified that the TNM is T2, N0, M0. Okay, and as I said, we want this because we already know what we are looking for. We specify this in the data model. So now we want to develop this NLP model so we can automatically extract this information to the IDEA4RC capsules. Okay, then we can query it, process it, whatever. Yeah, so this is how NLP works. Basically, we have this manually annotated example. Okay, so the previous slide was showing the full text, okay, and some highlights that are related to some information, okay, the T, the N, and the M. So this is what we call a manually annotated example. So somebody went over the text, he or she read the text and highlighted the parts that are interesting for identifying some information. So the idea is that if we provide enough examples to our NLP model, it will learn to do it on its own, right? So this is how it works. We will get some examples and we can go ahead with the NLP models. Why is this important? Okay, again, we have lots of relevant information buried in the HRs. So for instance, the Istituto Nazionale dei Tumori in Italy reported that they have like a lot of information, in this case, 25 out of 220 variables structured. Okay, this is an estimation. So they have a lot of information in form of free text. Okay. Also, this hospital coming from Poland, the Maria Sklodowska-Curie National Institute, okay, an oncology center, needs NLP even to find the condition, and the condition means basically the cancer type that the patient has been diagnosed. Okay, so this is also like quite a basic information that they already need NLP to obtain it. Okay, and finally, also a good example is the FPNS, the Fundación Profesor Novoa Santos hospital in Spain, that only has also 60 out of 220 variables structured. Also, this is an estimation, okay? So it is really important because there is a lot of information buried in text. And currently, when we research about cancer, we need to do a lot of manual work, okay? So we, clinicians, in this case, they sit down in their offices and they get some paperwork, they start looking at the databases and so on, and they need to mix a lot of things in order to do research. And this is a really complex thing to do. However, for NLP, there are challenges, of course. In our case, we have 10 centers. That means that we have 7 different languages, and this is quite a challenge for the models, for the AI models that we train and we use. Also, medical writing is a mess. We all know how doctors write. And of course, we need annotations for the model to learn. This is what I explained in the previous slide. So we need to somebody read the notes, explain the notes, highlight some text, and relate it to do some information. Okay, so and we need enough examples so the model can learn to do it automatically. Okay, and this is also a problem because it is challenging to find people that can do this and have the time and effort and can spend the effort to do it. Okay. Also, additionally, as I said, temporal rules are really important. So we need to identify the dates when things happen. And this is also difficult for the NLP models. So how we do it? Okay, so we are, in the current approach, we are using a large language model to do it. So there is no data leakage. We train the model and then we only deploy it in the hospital. So the data never leaves. And this is a simplification of the process, but I will try to explain basically how it works, okay? So first of all, we provide to the large language model, so this can be something similar to ChatGPT, let's suppose. We provide the task description, okay? So you can read it here. So we tell the model, you are an expert medical assistant, skilled in extracting key medical information from free text, okay? So we are just saying, okay, you need to do this, okay? And we can continue talking now. So it says, hello, got it, go ahead, okay? Then we provide some instructions, simple instructions, which are read the medical note and use the associated highlight to complete the most appropriate template from the various templates below, okay? So the idea is that we will provide this, the full text, okay? If I'm going back, we will provide the full note from here, okay? All the text written in black. And we will tell the model, okay, now I want you to use this output template so and fill them so we can obtain the information, right? So here you can see age at diagnosis, put age years. So the model needs to provide this output template and provide the age between the square brackets, okay? The same for patient's BMI and many other information, okay? So the idea is we ask the model, okay, now output it in this format. Okay, so then what we do is we provide some examples for the model, okay, so it really understands what it needs to do. And in this case, you see the example 1, example 2, blah, blah. So in this case, the example 1, this is the medical note, which is written in Polish, because currently we are testing Polish free texts. And we provide the medical note, and then we provide the highlighted text, which is patient lat 54, okay? And finally, we provide the annotation. So the annotation, this sentence from here is what we expect the model to output. So we expect that the model outputs age at diagnosis is 34 years. So then we can get this 34 from the output and put it in the IDEA4RC environment, in the IDEA4RC capsule, okay? Yeah, so basically that's it. Then what we pass to the model, we upload all the notes coming from a patient, and it gets all the information that we want, okay? And that's it. That is how it works. So the results, we are still working on the models and waiting for more data, but it really seems promising. So we tested this on Polish data and with only 20 full patient examples, okay, which are fairly few, okay? And for some basic information, like the age, BMI, and so on, the examples that I gave just in the previous slides, we are having a 71% accuracy. That it means that out of 10 elements, we are getting 7 right, okay, which is quite good. So we are getting a lot of information properly. And this is really good because also we are working with Polish, and most models are not that good working with Polish, okay? So we hope that maybe with other languages it can be even better. Of course, there are more difficult information. We can talk about the stages, information related to diagnosis, treatments, and so on. We believe it will hit like around 60%, depending on the information and the case. But we think that we can get a lot of information from here, okay? So this is important. Finally, I have like the full explanation of the data flow from the very beginning to the end. Yeah, so basically we start with a patient, okay, which is treated in a hospital with a doctor during months or years. And then what happens is the doctor, she or he writes, and all this information goes into the hospital's database, okay? This can be in free text, but also, as I said before, we can have some structured information. Then here is where the IDEA4RC project starts. What we do is we first extract the structured data, okay? We put it in an Excel file, in an Excel table, and we also get the text from the databases, okay? And what we do is we use the IDEA4RC NLP tools, okay? And output the information the way I just explained in the previous slides. And from there, what we do is we join basically the structured data and the output we got from the NLP models, and we translate the data into the IDEA4RC data model, okay? So we join this Excel file and the output coming from here, we join it into another Excel file, let's say, and what we basically do is with this joint version of the information, we put it into the capsule, and then the capsule can process the data, can retrieve the data, and so on. So this is basically how we work for the ingestion part or the population part of the IDEA4RC. And that's it. So thank you, everybody. So I think that we have now like 5 minutes for questions or so.
Yes, thanks a lot, Unai, for the very insightful presentation. And now, yes, we can welcome our questions from our participants. So please, you can either raise your hand or using the chat. Okay, we have a first question from Sergi Aguilo. Sorry for misspelling your name. How is the data secured in the capsule? Is it encrypted?
So, Sergi, I think that the best person to to answer this question is Eugenio. And he will, yes, and he will provide the explanation on this probably afterwards, right?
Yes, we will have the next Q&A session after Eugenio presentation, so we can address this question. Thank you, Sergi. Now, Annalisa would like to jump in. Please, Annalisa. Annalisa is our project coordinator.
Yes, sorry, I should know, but Unai, can you please go back to your last slide?
Yes, let me.
Yeah.
I cannot. I don't know why. Okay, yeah. This one, yeah.
Okay. So what I think could be interesting to try to explain a little bit better is what do you mean with this hospital database, and whether the same hospital database, so one database will basically contain structured and unstructured data, and this database will go into the IDEA4RC capsule, or you have some structured data in the hospital database.
Mm-hmm.
And then
yes,
this
so really...
database will remain with empty information, or so just to clarify how many database and how much, okay, they will represent real database or only temporary, okay, storage for data until the full data set is in the capsule.
Okay, so this was an oversimplification maybe of the problem, okay, for demonstration purposes, obviously. So here the reality is that hospitals usually have many databases, okay? They have databases for different departments, also for different things, like they may have database for oncology reports, but another one for radiology reports, and another one for patients' demographic data, and so on. So in this step, what happens in the IDEA4RC project, is that the data managers of each hospital really needs to identify where is this data located, and if they need to get information from 7 different databases, they need to go ahead and get it from like each of the different databases, right? And this term, which I used, extract, it's probably not correct. What we are doing is copying the data, right? So we are not getting out the information from the hospital database, and in this way we delete the information from within the hospital. We are just copying the information from each of the hospitals, and then we put that into the IDEA4RC capsule. So I don't know whether this is what you asked, Annalisa, or you want more clarification on the topic.
Before the others is clear, it's just to say that then we need to extract, we include them in what you named the structured data, that what is it? So which is the support?
Yeah, so I mean, so here what we try to represent is that there are 2 different types of data into the hospital's database. So structured data basically means that information that is already stored in a way that we can really identify, right? So the age we know is a number, and probably we have, like, each data manager knows where to get automatically the information for the age of a patient really efficiently, like really fast, let's say. Now the problem is that if I ask a data manager to get the stage of cancer, he or she may tell me, okay, for this, we probably need to go into the oncology reports, which are written in free text.
No, Unai, this is clear, but once they have identified the variable, they have to put it into, we provided them an Excel file, okay?
Yes.
This is what I'm trying, okay,
Yes.
to ask you to better explain that
Yes.
that the structured data extracted from the different data sources or databases in the hospital have to be basically linked with a predefined,
Yes.
we name it Excel. I mean, that was provided by the project, because again, it was specific for the project. And again, is linked to the data model. So it's not automatic that all these structured data, once extracted, will go as they are in the IDEA4RC capsule.
Yes, absolutely. Yeah, so here we have like this step, where we are extracting the structured data. This goes into an Excel file. And as Annalisa said, this Excel file has some specific format, that we ask the data managers to fill, And what we do with this specific format is we help the information to get into the IDEA4RC data model specifications. So in this way, we are this is like the step of harmonizing the data, basically, where we join the data, we ask the data managers to put the data into this Excel file, into the proper columns and the proper rows, and then we can continue with the NLP, join the information, and put it in the capsule. So yes, this is some kind of manual step where we are asking data managers to put the data in the correct place. That's it. Yes.
Thank you, Unai, for clarifying. We have more questions. So from Sergi Aguilo, what large language models are you using?
Yes, so Sergi, we are currently using Llama 3.1, so we tested different approaches. We tested using a model which is called T5, which is not a large language model per se. Then we tried to use this kind of Llama 3.1. We used both the base version and the instructed version. The results we are getting, it seems that the instructed version is better than the base version, as we expected. And also we tried using a model which is universal near, which is also based in Llama. But the current results, the ones I reported, are coming from Llama 3.1. It is possible that in the future we will probably test a few other models.
Thank you, Unai. Let's jump to the next question. How many NLP-based data extraction trainings from free text medical annotation have been done per each rare cancer type and per each language? This is a question from Antonello Manocchio.
Yeah, thank you for the question. This is a good one. We are still currently in the process of getting the data, So unfortunately, we only have the examples coming from the Poly Center. So in this case, the results that I reported in the previous slides, this one from here, so we got 25 full patients annotated, So when I say full patient, I mean that we got the cancer history for the patient, and we annotated all the information that was in that cancer history, It might be for months, year, it depends on the patient. So we got 25 patients, and we trained the model with 20 patients and tested on 5 patients, I know that 5 patients, it may seem really few, but then the annotations are, we have like many annotations for each of the data or for each of the variables. So like the reports from here, the 71% and so on, were tested like on 100 data points or something like this. But unfortunately, we still don't have all the annotation from all the centers. We will have them in the next months, where we will be able to assess better the models and to have a better evaluation. So we will try. The idea is that we will try to get some kind of semaphore where we can give feedback about how many and patients we need to annotate to get to start getting good results for the NLP. That's it. Yeah.
Thank you. So let's jump to the next question by Ines Enriquez. You mentioned that for the data model, you had to unify the used medical vocabularies. How was this done? Did you enforce one vocabulary in particular? Did you implement mappings between already existing vocabularies in the hospital's databases?
Also, really good question. Thank you for raising it. So, yeah, in this case, we used something which is Athena. Okay, so Athena is the Odyssey vocabulary. It's just a repository of all the medical terms, and this is a standard used for the common data model. So I think how Athena works is some kind of huge ontology, a huge graph, where almost every medical term is related to between different vocabularies, right? So we can have some kind of mapping between a term in SNOMED and a term in ICD, in this case, for instance, ICDO, whatever. So we decided to try to follow the codes coming from Athena so we can go back and forth between the different terminologies. However, what we did is for every possible value that we had in the data model, or the information or the variables and so on, we recorded a code, which is basically how we want to represent that value into the IDEA4RC environment. So when hospitals need to map the information, they need to get to use the code that we stated in the IDEA4RC data model. Okay, but as I said, because we are using this Athena repository for data managers, it's easier to go to Athena, okay, and check. Maybe let's suppose that we are using the IDEA4RC the code coming from SNOMED and they are using ICDO, so they can go to Athena, look for the term or the code in ICDO, and look for the mapping between ICDO to SNOMED, and in this way they can easily find the code. So that's the workflow that we decided to follow.
Thank you, Unai. I'm afraid we are running out of time, so I will give the floor to Eugenio, and then you can perhaps write your questions, your answers in the chat to the next question. So we can go ahead with Eugenio.
Sure, thanks. Thank you, everyone.
You can share your screen.
Okay. Are you able to see the presentation, or not yet?
Yes.
Are you able to see in presentation mode?
Yes.
Okay. So good afternoon again, and now it's my turn. Okay. After all the magic that Unai has been talking about until now happened, the data are located inside the capsule. But the point is, what is the IDEA4RC capsule? Looking at the definition that the project TEDAS is defining in the context of European health data space, we can imagine that the IDEA4RC capsule is what they call a secure processing environment in the context of European health data space. European health data space is the incoming regulation of European Commission that will provide a way that will overcome all the problem that GDPR has introduced on the sharing of healthcare data. Okay, in a very nutshell. But now, what is more in detail a secure processing environment? So we can imagine a secure processing environment as a protected digital space where sensitive health data can be accessed and analyzed only locally in the system, granting a high level of privacy and security. Okay. In this way, we are able to enhance privacy, compliance and protection against cyber threat, because we avoid any kind of data sharing, but at the same time, we are able to allow authorized user to perform data processing only inside the local environment without never transferring sensible data. Okay, as Unai said before, every hospital in IDEA4RC is the owner of its capsule. Okay, so we have 11 centers and we have always 11 capsules that in some way are enabled to perform local data processing. And now I will explain now. Now, how we protect this capsule? The basic security model that we are using in IDEA4RC is called Zero Trust. Okay, what does it mean? Zero Trust is a security approach where trust is never granted. Okay, the project, the system will always verify identity and credential in every operation that will happen on the system. Okay, and there is this continuous process of validation and verification of identity every time something or someone or a device want to perform some action inside the system. Okay, this approach, Zero Trust, is also the recommendation of NIS2 directive, that is the new European cybersecurity recommendation, and also it is mentioned in European Health Data Space recommendation. Okay, now if you want to have a very high-level overview on what is Zero Trust, you can imagine the actual approach to the security like a castle. Okay, a medieval castle. You have one entry door, and once you are inside this inside the door, you can do anything, and you can access to every room of the castle. When you are in a Zero Trust based approach, you don't have this approach because the castle is divided in many castles. And for every resource and every room that we have in the castle, we have a locked door. So you have always to provide the credential and policy associated to your identity to access to a specific room. Okay, now a bit more technical in detail. What Zero Trust model grant in the specific use case of IDEA4RC? We are granting data encryption. We have different level of data encryption. We have data encryption at rest, in transit. We have encryption when there is user-to-service communication, and we have mutual TLS security for service-to-service communication. This is something that is the basis of Zero Trust that comes with every tool that you use for Zero Trust. We have a strict access control that I will explain later. Also secure analytics that I will go more in detail in a few slides. Continuous strict monitoring that is a basis of Zero Trust. Compliance with the new EU regulation, because it's the novel approach that European Commission is promoting. And in our case, we have no data extraction, so we have the reduction of data attack surface. Okay, now let's see more in detail these two aspects that are very specific of the IDEA4RC capsule and secure processing environment. Okay. How we can grant data privacy and we can perform secure analytics without any data sharing and data extraction, because we are using two very important features that are associated to IDEA4RC. One is the federated learning, And the other one is the association to the federated learning of trusted and audited algorithms that are basically pieces of code of software that we are sure are not dealing with any breach on data. Okay. What is federated learning? Federated learning is a privacy-preserving technology where the data stays in its original location inside the capsule, and only the data or the algorithm is moving across all the capsule to learn on the local data. Okay. So what we are basically doing, instead of moving sensitive patient record, what we are moving are the computation. Okay. This is a very interesting video that Chiara, our colleague, provided to me that I think is very, very easy to understand for everyone, where we are presenting a federated way on perform the average on a distributed set of patients. Okay, in our use case, we have 3 centers. Okay, we perform locally the average on the 3 centers, and after the algorithm is passed through all the centers, we make the aggregation of the average. Okay. In this case, as you see, we do not have aggregated any data in any centralized infrastructure. What we have done is collected anonymized result for each one of the local capsule, and then we have aggregated to provide the final response. This very simple approach of distributed statistical analytics is also the basis on performing complex federated artificial intelligence learning approach. What happens when we do federated learning with artificial intelligence is that we have many iterations in every capsule because we have to go across all the data. That is not the case of the average. Okay, but it's basically exactly the same concept. Okay. Now, okay, we have seen that we have a way to perform some federated data analysis, but basically we also need what we have called an algorithm store, because even if federated learning grant privacy, we cannot allow to the researcher to run any code inside the capsule, because a researcher can be malicious and can design an algorithm that can extract relevant information from the anonymized result. So what we have done with our colleague of Vantage6, we have created an algorithm store that is basically a place where analytic and federated learning algorithms are stored, validated, and trusted, because we have performed the data protection impact assessment on every algorithm to ensure that the aggregating and anonymized result provided by the algorithm does not imply any kind of data breach. Okay. And basically, you can imagine our algorithm store like an app store where we are not providing application, but we are providing algorithm that can be injected inside the federated learning platform that then can be executed in the capsule. And we are pretty sure that in this way, we are enhancing the privacy approach against data sharing. Okay. Now, let's also see a bit more in detail how stuffs are connected with each other with the concept of strict access control. Okay. in IDEA4RC, we have a component that is connected to the capsule that is called the governance layer. Okay, the governance layer is the component that assists the IDEA4RC researcher when they want to ask to the system to perform some data analysis. Okay, so they a researcher inside the governance layer fill a data permit application, and once this data permit application is evaluated by every center that owns the capsule, it will be enabled to perform some analysis through the federated learning framework. Okay. Now, how would the SP verify the access and know who can do that? Because governance layers are connected with all the capsule, and the capsule has constantly verify identity and permission, ask everything every time that a researcher make a request for a computation to the governance layer, say, hey, can this user perform this action? And if the user has a valid data permit, the action is executed. If not, it's rejected. Okay, and in a nutshell, so the IDEA4RC capsule is a secure processing environment that ensures a safe and ethical use of health data for race cancer research and innovation in the context of our project. Okay, so I don't know if you have some question. Now I'm free for you and able to solve your tasks.
Thank you, Eugenio, for the very comprehensive overview. Let's see. So there were some questions on the capsule before that you already addressed via the chat. But
Yeah.
I don't know if you would like to expand more on the previous questions now in person.
The point is that I'm not able to see the question.
You should be.
Okay, yeah. Now I'm okay. So the first question was about data secured in the capsule. As I said at the beginning, we are using zero trust, and zero trust stress a lot on the encryption, because zero trust expect that not only the communication between user and the entry point of the system is encrypted, but encryption is always applied even into service-to-service communication, and also data when stored are encrypted. In addition, we are evaluating because we saw that we have some center that even if you present to them a very secure approach like zero trust, they are still not fine with this, because zero trust implies that you need a stack that is very innovative, that may not all the center can use, so they have to make a contract with the cloud provider, and so, and they do not trust in the cloud provider. So in order to remove the concept of trust in a cloud provider, we are also looking at some advanced technology like confidential computing that basically reduce the boundary of attack surface to the only owner of the capsule, even if you put your capsule in a provider in China. Okay, that is the maximum level of trustiness that at the moment technology can provide, but it is not yet integrated. I don't know if we will do it. Then there was what happened to the capsule did not get this. I understand that when this question was performed, this was referring to the NLP process explained by Unai. A capsule, when is created, need to ensure a minimal level of quality of the data that are inserted inside the capsule. If this minimal quality of level of quality of data is not reached. Data is basically rejected, and the data manager inside the center need to make a more deep annotated, a more deep manual work, basically. Okay, and this is more or less what we want to address. Some
There is another question from Sergi Aguilo. Is this approach improving the AI models and all the federated learning maintainable across time?
This is a very interesting question, and thank you very much for raising it. There is a problem with federated learning at the moment because we have a lot of platforms that are doing federated learning, but we do not have a standardized way to provide interoperability across those platforms. We are working on a systematic deep review on how the different platforms work and what could be an approach to provide the interoperability across federated learning. Okay, there are some initiatives that can solve the problem when you are moving an AI model, but there is no solution for federated analytics. Okay, and this is a very important breach that, a very important niche that need to be covered if we want to promote federated learning as a solution for EHDS, and it's a recommendation that we are providing to TEDAS on the secure processing environment. I hope that this answer to your question.
Thanks a lot, Eugenio.
You're welcome.
I think we can now launch the opinion poll. So it will be very quick. You can just answer live with your device. It will take 1 minute, but this is very helpful for us to have your opinion as an expert in the field on the different topics. So thank you for filling in the questions in the poll. So the questions from the opinion poll should appear as a pop-up window. Yes, I now can see that people are participating. Thank you. And after the opinion poll, I will recap briefly the next webinars, the upcoming one in March and in April. So please stay connected a couple more minutes. Thank you for your understanding and sorry for running out of time. Thank you. So we can stop the poll and briefly recap our next appointments. I will be very, very quick. So thank you for staying with us. So as you may recall, we have two more webinars scheduled, one in March and the other one in April. And the next one will be about the new EU regulation about the secondary use of health data. So how the new regulation basically allows and facilitates the access and reuse of health data across borders for the advanced research and policy making. So we will have as a speaker our legal researcher at the European Center for Cancer Privacy, Vasiliki Tsionpanidou, who will give an overview of the HDS and will explain what are really the changes that will bring into data sharing for research. You will receive the registration link with a follow-up email by Zoom. And of course, all community members will be also reached out. So we really hope to have you to the next webinar as well. And before leaving, I really would like to acknowledge our speakers, Unai and Eugenio, and also the amazing work of our communication experts. So Chiara Sabelli for having developed the beautiful graphics and animations that you have seen across the webinar. And for really like developing with us the content and the tone that really helps when it gets to communicate science. And then Maria Luisa Clementi, that is has created and is updating continuously the community webpage. And last but not least, our IDEA4RC project coordinator, Annalisa Trama from the National Cancer Institute in Milan. So thank you everyone for your attention, and I really hope we can stay in touch by either joining our community or subscribing to our newsletter. It was really a pleasure to have you, and I really wish you a nice evening, and see you in March. Bye, everyone.
Bye bye.
Thank you, Lydia. Bye bye.